Hello and welcome to PMCD MATHS Teaching, and this session we're looking at volumes and surface areas of pyramids, cones, spheres and frustums, and the rationale is coming up. And the sequence of teaching. Right, so what I'm going to say about this particular session, I'm not going into necessarily how to teach, how to find the volumes and surface areas, because a large amount of that is using formulae which you substitute into. And if you've done a lot of substitution, they should be able to do this reasonably confidently. My focus here is really trying to open our minds up to how we can make this more interesting. And as I said in the rationale, you have textbooks will have a lot of just diagrams of these solids that you have to find, and I think they're useful definitely to get your skill set up. And if you choose carefully, you can get a wide range of examples to use there. But what I like to do, and what I like to think about is, what pyramids, what cones, what cylinders, etc., have they seen in their own life, or are they aware of, that might be interesting to find out. So we're looking at the Great Pyramid of Giza here, and this is really what I'm focusing this session on, is how can we make this a bit more interesting? How can we make this a bit more challenging? I mean, some of the tasks that you see don't have a real practical purpose. They're just like out of curiosity. What would the answer to this be? So the Great Pyramid at Giza, the volume of the pyramid and the surface area of the pyramid. Okay, so they've got two things to think about with that one there. And I've, with a bit of research yourselves, you can find specifications for different solids that you'll find in famous places around the earth, around the world. You can find this information. This is the information that I found and used in this question here. So it does take a little bit of work, but as I said, as I always say, you're developing a lesson that you're actually going to look forward to teaching as well. And if you're happy with teaching it, that automatically gets translated into the students as well. They see something that they recognise as well, and some of them might even have been there. It really is motivating for them. So, I've volume surface area of the pyramid at Giza. And I've found this, this an American grain in here, the volume of grain that this grain feeder can hold. So we'd have done the formulas by this time. They'd need to know the cone and the cylinder, obviously, by this stage. And we'll talk about a little bit more about the formulas in a little while. But let's assume at this stage you've already given those formulas and they're using those. In this case, I think I've chopped off the top, so I'm not including that top part. I'm only talking about from 6.77 meters of a grain hopper. But again, this is me just going online, finding images, finding information. And sometimes you teach them something about other areas of life they may not be even, ever come into contact with. Okay, so the whole point that you've got to dry grain before it's eaten. Do they know that? Is it of interest? Well, I think it is. It fits into our lives, doesn't it? Okay, what else have we got? We've got conical party hats. So the frozen themes always gets a bit of a laugh. Okay, there's enough information there to work out the area of the card that's needed for one of these hats from knowing about the surface area, the curved surface area of a cone. Okay, now again, just a little bit of thought, a little bit of research there, you'll get something that is applicable to how they are, to what they do in their own lives. Maybe not all Frozen fans, but that's sort of an ironic question, I suppose. Going on to spheres, you've got the formula sphere, and I'll talk about formulas quickly now as well, because although we're probably looking at this at a higher level at GCSE doing this sort of work, so you've got the formulas, okay, and you've got a question about the Earth, and then well, why is that formula 4/3 pi r cubed? Why is that surface area 4 pi r squared? Now again, you don't have to go into why it's true, but you can say, well, there is a reason. It's not just magical. We can actually prove this, and if you get to A level, this might be something that you actually get a chance to do, is to show how that formula exists, because it's that level of working. And to them at GCSE, this is going to look like another language. But it should be motivating for them. Say, actually, no, I could get to that. Or say, you know, find out in your own time. Can you find out what's going on here? For those really motivated at the high end, they may be interested in that. The other formula that I said, you know, as far as I can, I like to be able to show where formulas have come from, rather than just plonking a formula down, you substitute in. You really are, you know, just operating with what you're given. Then you're not really having to think about it. And I think they should always be asking why. So the curved surface area of a cone is another one here. Okay, so I like to do this. Okay, we've got W is this the circumference of the cone. When we lay this out into a sector, W just becomes the length of that arc. So if you get expressions for W for both, you know the area is theta over 360 times pi L squared for this piece of card, not R, because R is the radius of the cone. They find theta in terms of R and L, and then they can work out the area, the curved surface area from there. Okay, it's a little challenge. I always end up doing this before the lesson as well, just to make sure I'm pretty slick with it, so I don't want to stutter in the lesson with that. But it's always a good idea to practice these things so that you don't get stuck at the board. And the circular base is quite an easy part, isn't it? So like I said, I like to show those formulas as much as possible. As you see with sphere, I'm not going to spend too long on that. Just say, look, this is, you can be doing this by the end of A level. This is something that you could be doing. So once we've summarised the sort of those solids, I've got a cylinder there with curved surface area. I mean, again, you can show that surface area quite easily, can't you? And you'll see a lot of people using this second formula, and you say, well, where does that come from? Oh, I don't know, I've just learnt it. Well, think about it. You know, where does that come from? If we draw the neck, how can we show that this surface area is 2 pi r squared plus 2 pi r RH? Keep challenging those students to be able to explain what they're doing, rather than just relying on a set of formulae. Same with here. It's been factorized again, hasn't it? And you might even go into, you know, the fact that the surface area is the rate of change of the volume. You might even get into that. You know, it's like a little, that 4 pi r squared, if they've got any experience of differentiation at all. Some people still do the pre-standard maths qualification where there's an intro to calculus. By differentiating the volume, you do get the formula for the area. Why is that? You know, there might be a question for A level as well when you come on to A level. It's all worth thinking about. Remember, when you're teaching this, you're not just teaching with GCSE as your endpoint. You want to think about, how can I just stretch them into A level without actually setting the A level work? Well, how can I get them to start thinking in a way that you expect an A level student to think? Okay, moving on, frustums. So I'll start off with, and I go about and I do nerdy measurements. I will measure cups. I will measure badges on cars. I'll measure things so that we've got something realistic. What is the capacity of this water cup? You've got a chance here to talk about the difference between capacity and volume at this stage as well. What's the capacity of that? And it's a frustum. It seems quite easy, but it is a frustum, isn't it? Okay, so we've got a cone with a cone chopped off, and then, you know, like I said, question which doesn't have any real purpose in this one here, really, but can of Coke, again, measured. How many cans of Coke would we need to fill this classroom bin? And that's me. But again, it's curiosity. You've got to be, well, how many cans of Coke? Sometimes the answers are surprising, you know, just out of interest. These things are surprising. But maths isn't just about practical applications. It's about your curiosity. It's about, I don't know, sometimes just nerdy facts that we like to find out. And here's a GCSE style type question, which you can get from any exam board. Will have examples of these, I'm pretty sure. Okay. Another style there. The volume of the sphere is 3 times the volume of the cone, so we've got a bit of volume scale factors going on there. This one I've always liked as well, the egg timer question. They really do have to think about this, because obviously the sand falls in and fills up the hemisphere first, then they've got to work out how high up that cylinder and the bottom half of that sand timer, how far that gets up. And then one of the latest things I've been doing here, let me just make that a little bit bigger so we can see that. What we've got is Lindor. Now, these are the massive Lindor sweets that contain these smaller ones. So it says each 550 gram Lindor ball contains 44 individual mint truffles. So you can work out the mass of one truffle there. How many indoors can fit in this box? I've not given you much information there. This is a challenging question here. But what information do they need to know? They can work out the mass. Okay, they can work out the mass. When they've worked out, they need to know the average density of chocolate here. By knowing the mass and density, they can work out the volume of each ball. Once they work out the volume of the ball, and there's 44 of each ball, they can then start working out. They can work out the radius of each ball. Once they work out the radius, they can start working it in there. Now, again, you'll get answers where it assumes that every bit of space in that box can be filled with chocolate. That would only be true if it is melted. So there's a lot, and then they might think about, okay, well, if the radius is this such and such, how many can I get in there with the radius? What's the maximum number? So this is a multifaceted question, really. They can really be challenged with this, to have to think about what's going on here. And the latest one that I did, I think this was in the World Cup year, actually. I started looking at getting specifications for the World Cup as well. And so, well, let's simplify it. So I've got all this information. Okay. And then just trying to make it a little bit easier. We've got like a frustum here, maybe a cylinder here, a hemisphere on the top, a frustum at the bottom here. What's the surface area? What's the volume from the measurements that I've got there? Okay, and again, that was topical. That was around the time of the World Cup. You also notice with this, you can actually get, because I was thinking, well, it isn't a perfect hemisphere, is it here? It's not a perfect hemisphere. You might want to look at situations where you've got a partial sphere. And again, we're pushing this now. This is the limits, really, of where you would probably go at GCSE. But again, this can be used, you can use integration to, volumes of revolution to work these ones out as well. So this is, it's fascinating. I think they've actually got a formula for it down here as well. Yeah, you've got a formula. You can prove that formula works as well. But this takes us beyond where we go at GCSE and probably beyond where we go at A-level. But it's interesting. If it's interesting to us, it's going to be interesting to those people that are really into their maths, and we're talking about the higher end, and you should have a lot of fun with it. So there's lots of options there. I mean, this, like I said, this session is more about ideas than actual teaching methods or how to do it, because essentially a lot of this is substitution. The only thing I would say about it is focus on layout. How do you want them to lay it out? Are they labeling their working? I mean, this is a big thing. That can be a problem, I think. The mathematical communication here, they're just going to write loads of writing down here, or are they going to say, okay, volume of cylinder is a little subtitle, volume of cone as a little subtitle, so that if somebody else was working, they could pick up their working, following on with their working, they pick their working up quite easily, and also it's easy for them to revise from. Okay, not such a long one there. I hope that you found that interesting and that you've got some ideas from that. Thanks for watching, and I'll see you next time.